Good day, my dear 9th class students. We are going to continue the chapter 4, which we started a couple of days back. We talked about lines and angles. There in the part 1 we learned some, and then we are going to continue that. The whole lesson may be presented. I may present them in 4 segments, 4 parts. The first part we already covered, and we'll talk about the second part today. Prior to that, I will brush up your memory for what I taught the previous day, because that way I can bring you online with what I am thinking. Once you come online, once you are oriented, once you come in line with what I am saying, then it becomes easier for you as well as to me. So first let us talk about a point. The point is represented by a letter A, or it can be P, or it can be Z. Any letter, single letter, and it is represented by a capital letter. It is a capital letter. It has to be a capital letter. You cannot represent that as a small with a small letter A. That's a convention. That is a way. That's the way. You cannot, let's say, for example, a boy. You can't name a boy as a Padmini. So you will call Padma Rao. You cannot call it as Padmini. So similarly, here for a point, you have to designate by a point, and then you have to show represented by a line, a capital letter. Then you have what is called a ray. This is a point. 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 Now we are talking about a ray. A ray has a starting point, and it can go any long, any length. It can go any length. For example, sun's rays. Sun's rays start from the sun and go all the way. So here, again, this is a point. We call it as any letter, M. I will call it as M here. And sometimes you can put a point here and Mn. You can call it as Mn as the ray, and you represent it by an arrow like that. Arrow. So a ray has one end point, but there is no end point. Other side there is no end point. Also, ray does not have any length. We know that the ray starts at one point. That's it. That's all we know. And then I will explain to you about a line. Generally, when we say a line, it is always a straight line. If it is a curved line, then we call it as a curved line. Again, a closed curve, an open curve, like that. So, when you say a line is normally represented by small letters M, L, M, N. Just like a point is represented by a capital letter, here for a line, you have to represent by L, M, and like that. You can call even A, B, C, A, small B, small c, etc. But the line does not have a specific length. Rama can draw a line like this. He says that is a line. Susila will draw a line like this all the way here. That is also a line. And Gopal will draw a line like this. That is also a line. That means line does not have any length. There is no starting point, there is no end point. So that's what is called a line. This is called line, L-I-N-E. I know all this information has been taught to you in earlier classes, but you have to have, lines are so fundamental, you have to have absolute knowledge. No doubt at all. So you have to have absolute knowledge so that we can study the other concepts of geometry and all kinds of things. Unless you understand a line and certain other things, we cannot progress very well. So this is a line. Then suppose you have in a line, what I will do is I will mark 2 points. Let us say this is L, this is M. I will mark 2 points. That means you can see LM has a fixed length. Depending on where L is located, depending on where M is located, it has a fixed length. So this is this we call it as line segment. Segment, S-E-G-M-E-N-T. This is a line segment. As you can see here, a line segment has 2 endpoints, and also it has a definite length. So here we call it as LM. You can draw a line like that. That is called line segment. So sometimes every time if you want to draw a line, it may become a little bit strenuous. So normally when you show a line segment LM or PQ, we may not write this line every time. Even if it is not written, LM means it represents a line segment. It starts at M, L, and that's at N set M. Now, one thing, important thing you need to know is, like I said, a line segment has 2 endpoints. Now, your line segment, you can call it as LM or ML. Both are same. Okay? Line segment, you can go in the forward direction or in the reverse direction. In both ways, you can call it as a line segment. So, you learned about a line segment. Then, finally, in the introduction, I want to talk to you about a closed curve. A closed curve. This is a closed curve. That means that if you start at a closed curve, first of all, a curve. Curve is not a straight line. It is a curved line. Now, curve is formed out of a curved line. That's why it is called curve. Now, in the case of a curve, you start at one point, and if you reach the same point, then it is called a closed curve. Now, if you don't, if you cannot, you stop it somewhere else, then it is called, it doesn't have to be like this. Suppose I draw a line like this, So this is not a closed curve. Because, why? Because if you start at one point, you are not coming back to the same point. That's why it is called an open curve. So far, I talked to you about a point, a ray. Ray I did not write here. This is a ray, R-A-Y. This is a ray. Then I talked to you about line segment, and then representation, their representation, and then a closed curve and open curve. So here, for example, when you say LM has a definite length and 2 endpoints, then you can call it as LM is equal to 7.5 centimeters. What does it mean? That means if you draw the line LM equals 7.5 centimeters, that means with a scale, if you measure the distance between L and M is 7.5 centimeters, like that. Okay, so I hope you understood the fundamentals of it. Now, when we talk about, we extend our analysis or the class to the lines, well, there are parallel lines, intersecting lines, concurrent lines, coincident lines, like that. And then we move to angles, the different types of angles and all that. So now, having understood what a point is, what a ray is, having understood what a point is, what a ray is, what a line is, what a line segment is, what is a closed curve, and what is an open curve. Now we move on to lines. In the case of lines, depending on the relative location between the lines can be parallel, lines can be intersecting, lines can be concurrent, and then lines can be coincident. Now, I will first tell you that lines which are parallel. When 2 lines or these two lines are said to be parallel. We show it as with a symbol like that. That means these two lines are parallel. Now since it is a line, you call it as L and M. Right? Okay. L and M are parallel. What does it mean? This distance between these two lines, this distance between the two lines is always same. Then the lines are called parallel. P-A-R-A-L-L-E-L. Two L's ఉంటాయి. జ్ఞాపకం. So, if the distance between two lines is always the same, then the lines are called parallel lines. Then what you have is intersecting lines. Intersecting, the point మనం అంటాం bubble junction, intersection, like that. That means two lines will intersect, two streets will intersect. So there, this is a point of, this point is called point of intersection. INTERSECTION. This one is the point of intersection. This is one line. Say, let us say L. This is another line M. So these two lines L and M are intersecting at a point of, let us say, O. Okay? These two lines are called as intersecting lines. First I told you about the parallel lines. Parallel lines will never meet. So the example is, famous example is the railway track and the rods in a window. They never meet. Similarly, you can see here, the line here and this line here. They will never meet. Similarly, these two lines, you take this line and this line. Will they meet? No, they will not meet. So they are called parallel lines because the distance between these two lines here, the distance between the two lines here is always the same. So they are called parallel lines. Then you have the intersecting lines. Okay. Then what is meant by concurrent lines? Concurrent lines means if you take a point, you can draw through a point any number of lines. I draw one line like this. Gopal will draw a line like this. Saumitri will draw a line like this. Roja will draw a line like this. Okay? Like that. So, but the thing is, all the lines are going through the same point. Then these lines are called concurrent lines. C-O-N-C-U-R-R-E-N-T. Concurrent lines. Okay? Now you learned about parallel lines, intersecting lines, concurrent lines. Now we talk about coincident lines. Coincident lines are simply, say, I have the money in my pocket. We both have the same amount of money. Then we say coincide. Similarly, if you have a line here and there is another line like that, well, then these two lines here, L and M, let us say L and M, these two are coincident. Coincident, there is only, they are one and the same. So then you call it as coincident lines. Now, having known what a parallel line, what is a set of parallel lines? Sorry, not about a parallel line. Set of parallel lines and intersecting lines, concurrent lines and coincident lines. Now we talk about angles. Suppose when you have a line like this, let us say there is a line like that and there is another line like that. These two are intersecting at this point O. We can call it as this is one, OA is one ray and OB is another ray. This is the angle formed. This is the angle AOB. We call it as O. Angle, you represent that little bit slant line and you put O here. That means the angle is formed at the point, O. Now, there are certain rules, certain things. See, this angle and this angle is, they both are equal. Similarly, these two angles are equal. They are called vertically opposite angles. Vertically opposite, O-P-P-O-S-I-T-E, opposite angles. Okay? Alright. earlier. Now, suppose we have a long line, and you draw another line like that. Then this line and this line, this angle and this angle, these two angles, sum of these two angles is equal to 180 degrees. That means a straight angle in a straight line at a point, this angle is 180 degrees. So then these two angles are called linear pair. L-I-N-E-A-R, linear pair. This is a pair made on one line, linear line. That's why it's called linear pair. So if this is, let us say, this is 30 degrees. What is this angle? 150. Good. That's correct. This is 150. So let us say this angle is 40 degrees. What will be this angle, Krishna? 140. Good. Excellent. Very good. So 140 plus 40 is 180. Or 30 plus 150 is 180. So these two, the sum of these two angles is equal to 180 degrees. Then we call these two angles as linear pair. We also call it as supplementary angles. Supplementary angles. But there is a subtle difference between supplementary angles and linear pair. The linear pair has to be on one line, a line, and another line intersecting on that. Now, when I say supplementary angles, suppose I have a line like this angle, and suppose then this angle. Of course, these two combined is 180 degrees. Right? These two are combined is 180 degrees. Now, then we have what is called complementary angles. Complementary angle. In the case of complementary angles, the sum of the angles is equal to 90 degrees. This is 90 degrees. Suppose I have a line like this, there is an angle 30 degrees. So there is another line like that and another line like this. Let us say this is 60 degrees. Okay? These two, this is 60 and this is 30. So 60 plus 30 is equal to 90 degrees. Therefore, this angle and this angle, they are called as supplementary angles. One supplements the other. That's why they are called supplementary angles. I'm sorry, they are called complementary angles. Oh my God, I made a mistake. So, how come you guys, you never caught me? I told you supplementary angles is sum of the angles is equal to 180 degrees. Complementary angle is 90 degrees. I have a clue or a chittanta, a thumb rule. Why in examinations you will get a doubt which one is 90, which one is 180. 90, ఇప్పుడు మన ఏటున్నాయి, we have complementary. See, just now I made a mistake, we should not make. Then you have the supplementary. Okay? Complementary, supplementary. Now the way I remember is C comes in the case of the A, B, C, D, etc. Then you have P, Q, R, S. I will say S is larger than C because C comes first and then S. So C is complementary 90 degrees, S supplementary 180 degrees. Let's say just like a thumb rule, just to remember which one is what. Now we learned about complementary angles, supplementary angles, and then we also talked about linear pair. Now you talk about adjacent angles. Adjacent, adjacent means side by side. If somebody is sitting close to, by your side, then you say adjacent to each other. Similarly here, for example, let us say a line like this, this is some angle, that's 35 degrees, and there is another angle, let us say is 25 degrees, and another angle, let us say this is 50 degrees, like that. Okay? Now, this is one angle A, this is B, let us say C. Now, Adjacent angles. Adjacent angles means they have to be adjacent to each other. Now, incidentally, I want to tell you, when an angle is formed, this is one arm of the angle, this is the other arm of the angle. These two arms are meeting at point O. So that means when if an angle has to be formed, there should be two rays or two lines here intersecting at a common point. So here, this is one angle, this is another angle, this is the other angle. Adjacent means they have to be side by side. Now, I can say 35 degrees and 25 degrees are adjacent. I cannot say 35 degrees and 50 degrees are not adjacent. They are not adjacent. That means, you see, suppose on a table, one guy is sitting and the next guy. These two are adjacent to each other. I cannot say these two are adjacent. They are side by side. I don't know. So, similarly here, I can say 25 degrees and 50 degrees. 25 degrees and 50 degrees, they are adjacent. Understand that? So, do you understand me? 35 and 25, they are adjacent angles. 25 and 50 adjacent angles, but not 35 and 50. What does it really mean? What does it mean? So, here, this angle is 25 degrees, this angle is 35 degrees, this angle is 50 degrees. So here, now, why are we saying that 35 and 25 or 35 and 50 degrees are adjacent angles? In the case of the adjacent angle, there should be a common arm. Here, for example, let us say this is O, this is X, this is Y, this is Z, this is P. Okay, all right? Now, for angle 35 is formed by OX and OY. Now, angle 25 degrees is formed by OY and OZ. Now, in these two angles, you see, for example, let us say 35 degrees. For 35 degrees, it is formed by OX and OY. Right? Now, whereas 25 degrees, it is formed between OY and OZ. OY and OZ. You can see here, then there is a common arm. That is, OY is common to both 35 degrees and 25 degrees. That's why these two angles are called adjacent angles. Now, when you take, for example, 35 degrees, we call it a, for 35 degrees, we note it down, OX and OY. Now, for 50 degrees, it is OZ and OP. OZ and OP. Right? You can see here, there is no common arm here. So that's why 35 is 35 is OX and OY. And then you have 50 degrees OZ and OP. OZ and OP. So if you look at here, there is nothing, there is no common arm. That's why these two angles are not called adjacent angles. So you learned about adjacent angles, complementary angles, supplementary angles. Once again, I don't want you to make the same mistake. While I was teaching, I made a mistake there. Complementary angles are those angles which are the sum of the, normally you call it a theta 1 plus theta 2, or angle A plus angle B. If angle A plus angle B is equal to 90 degrees, then angles A and B are said to be complementary. A and B are AB, or angle A and angle B are complementary, etc. Whereas if A plus B is equal to 180 degrees, then angle A and angle B are said to be supplementary. Okay? Okay. Now, now one important thing that you want to know is that if you take now I told you, if you take a point, what is the angle formed at a point? This is equal to 360 degrees. I'll show you. Suppose if you draw a line like this. Now what is this angle? This is a linear pair. This angle is 180 degrees. Now if you take the other one, that's also 180 degrees. So the total angle formed at a point is 180 degrees plus 180 degrees. That's equal to 360 degrees. Okay? You understand me? Now, based on what I taught you so far, we want to do some exercises. We'll do that in the next session. That is the part 3. That is in part 3. Now, there are 4 exercises here. We have 4.1, 4.2, 4.3 and 4.4. 4 exercises. Each one has like something like 10 or 12 problems. Okay, it's all right. It's easy. It's not that difficult. But we'll talk about that in the next session. That is in part 3. But before that, I want you to read the textbook. Identify the difference between various types of angles, and then we will continue that in the next class. Thank you for watching the video. If you like it, you can forward it to somebody else and ask somebody to watch it. But more importantly, I am interested in questions from you. This whole effort is aimed at keeping the SRUJANA students the best students, as was done in the past. So we want to keep you busy, and we want to have the more fundamental knowledge. Okay. So I want to hear from you with all the questions. You have my phone number. That is the same 789-361-4045. This is my phone number as well as my WhatsApp number. Best thing is just to draw a line. You take a piece of paper, write down your questions, and then take a photo of it and send it. I'm telling you, I will be thrilled if I see a number of questions from my students. You can see that, you know that when I'm teaching a class, when somebody asks a question, I always encourage students to ask me questions. That's the only way I will be able to teach you what all I know. So once again, thank you students. Please definitely watch the video, take a textbook in front of you, and then you have questions, just give me a call.